Next, let's look at a combination of transformations. And what does that do? So on example 5, I want to write down what transformations do I see, and I want to verify it with technology. So if I see x minus 3, I'm thinking in that squared, so I'm going to move my parabola right 3. And then, since I'm adding 2, I'm going to have it go up 2. So my point for my parabola, my vertex for my parabola, is going to be to the right 3 and up 2. So let's take a look at that. So I've got, leave my parent function in there, and I'll say g of x equals x minus 3 in parentheses squared. And then what was the other one? And plus 2. And I'll go plus 2. And notice this point is moved to the right 3 and up 2. You can see that point 3, 2 there. That's why this is called vertex form, because it tells us where the vertex is at. If I take a look at example 6, I think I got my parentheses wrong there. That should be x plus 3. I'm going to say the square is supposed to be on the outside. So g of x equals x plus 3 squared minus 1. So if it's x plus 3, I'm going to move it to the left 3. And I'm going to move my vertex down 1. So my vertex is going to be at negative 3 and negative 1. Let's take a look here. So I'm going to change this to x plus 3 squared. And I'll change it to minus 1. And there we see our vertex is at negative 3 and negative 1. There you have it. Now let's take a look here at what happens when you multiply your function by something. If I multiply my function by something, I'm going to vertically stretch that out. So if I multiply it by a number bigger than 1, it's going to be stretched. It's going to make it thinner because I'm vertically stretching it. If it's less than 1 but more than 0, then I'm going to compress it. I'm going to push it down. I'm going to take each y value and push it down that far. Now, if it's inside the function, it's just the opposite. I'm going to horizontally move it. Kind of like before, when we moved it inside the function for a translation, inside was horizontal. See, it's a horizontal stretch and it's always the reciprocal. So it'll be 1 over a. So it'll be a horizontal compression by 1 over a and a vertical stretch if a is less than 1. So if I take a look at my examples here on example 7, I'm going to do a vertical stretch actually vertical compression because it's less than 1. So I'm going to say vertical compression by 1/2. I'm going to take each y value, I'm going to multiply it by 1/2. Let's see how that looks. So I'm going to go back to my decimals here. I'll do my parent function again. Only this time I'll have g of x. Let me delete that out, this stuff here. I'm going to go 1/2, and then I'm going to go x squared. And see what happens? Each y value has been pushed down by a factor of 1/2. Take each of these points, multiply them by 1/2, and I move it down that far. Now, inside our function, like on example 8, that's a horizontal compression. by 1 over 3. 1 over your a. So 1/3. So I'm going to take each of my x values, I'm going to multiply by 1/3 and keep the same y value. So let's take a look at how that looks. So let's get rid of my other function here. And so now we're going to say g of x equals, I'm going to go in parentheses, I'll go 3x, and then I'll square that. And notice what happens, I'm pulling it in by a factor of 3 for every x value. So it looks like it gets skinnier, okay? It kind of looks like a vertical stretch, doesn't it? It's horizontal compression.